per violation. Now, this is mentioned both to answer a commonly asked question and as an example of how this regulation is interpreted by the FCC. Any pigtails or antennas that are used with a wireless LAN in the ISM or UNII bands must be part of a certified system. So you need to be very, very careful with the type of radio frequency equipment that you choose to use. And due to these FCC regulations, you want to make sure that you have specified everything necessary to fit within their compliancy requirements. You want to be aware of even some companies that advertise that their equipment is legal. Remember that the FCC requirement states that it has to be certified as a system. And even though there are regular marketing companies now that are pushing out the sales of these Pringles can-like antennas, like www.cantenna.com is a good example, they do indicate that complying with FCC regulations is your responsibility. Their device does meet within the requirements of FCC, but if you add that to another system, remember, it's got to be certified as a complete system to fit into those requirements. So it's always going to be your responsibility anytime you have a high-gain antenna or any radio frequency equipment that you add to your wireless LAN. It's all got to be certified. You have to make sure that you fit within the FCC regulations. The FCC, the IEEE, the IETF, all of these standards organizations, what do? What does it mean? Why do we care? Why in the world do we have to worry so much about standards organizations? Well, I don't have that much money. That's why. Because if you do the wrong thing in your wireless network, you could be fined over $1 million per violation. You got 5 violations? That's a lot of money. I don't have that much. So right now, we learn about the standards organizations because it's that important. Also, for planning purposes, these standards organizations are the one that take all this technology that's emerging and they make standards out of it. So we can buy off-the-shelf equipment, save money, and have just as functional of a LAN that we would have had if we would have spent millions of dollars a few years ago. That's why standards organizations are so important, and that's what we're going to focus on right now. Our objective right now is to focus not only on the organizations that make all of this happen, but also on the standards that they produce. It is a good idea to relate directly the standards for each organization so that you understand kind of where they come from and know that they do meet a certain amount of compliancy with each other. And probably the biggest organization that does, of course, deal directly with wireless networking is the FCC, the Federal Communications Commission. All of what we do with radio frequency has got to comply with their regulations. As well as the IEEE, the Institute for Electronic and Electrical Engineers, is one of the primary standards bodies that actually takes compliant technologies and actually creates standards for the rest of us so that we can implement things based upon standards. We know that makes it so much easier and so much cost effective, and that's really what they're all about. They do have a specific set of standards which are focused on wireless LANs. We want to make sure that we are definitely familiar with those. There's also other major industry organizations that do participate and also adhere to FCC guidelines that will often produce other products for wireless networks. We want to get used to those as well in this particular area too. Now, the first standards organization that's very important, the first organization that we deal with is the FCC. The Federal Communications Commission is an independent United States government agency which directly reports to Congress. The FCC was established by the Communications Act of 1934 and is charged with regulating interstate and international communications by radio, television, wire, satellite, and cable. The FCC's jurisdiction is very broad, covers not only the 50 states and the District of Columbia, but also all of the U.S. possessions such as Puerto Rico, Guam, and the Virgin Islands. The FCC makes the laws which, within wireless LAN devices, must operate. The FCC does mandate where on the radio frequency spectrum wireless LANs are able to operate and at what power, using what transmission technologies, and how and where various pieces of wireless LAN hardware may be used. So it is very important to get very familiar with FCC. In fact, a large part of the information from this particular series is published in working public domain documents directly by the FCC. The Federal Communications Commission is a wealth of information when it comes to radio frequencies, understanding how they work, and understanding how to make your radio frequency network comply with their appropriate specifications. Probably two of the primary specifications that we deal with in wireless LANs are the ISM and UNII bands. The FCC establishes rules limiting which frequencies wireless LANs can use and the output power on each of these frequency bands. The FCC has specified that wireless LANs can use the industrial, scientific, and medical ISM bands, which are completely license-free. In addition to the ISM bands, the FCC specifies 3 unlicensed National Information Infrastructure bands, or UNII bands. Each of these is also license-free. Now, when implementing any wireless system on a license-free band, there's no requirement at all to petition the FCC for bandwidth and power needs. Limits on the power of transmission exist, but there's no procedure for receiving permission to transmit such power. Furthermore, there are no licensing requirements and thus no cost associated with licensing. The license-free nature of the ISM and UNII bands is very important because it allows entities like small businesses as well as households to be able to implement wireless systems and also fosters the growth of the wireless LAN market overall. Such freedom from licensing does carry with it a major disadvantage to license-free band users, however. The same license-free band that you use or intend to is also license-free to others. So suppose you install a wireless LAN segment in your home network. If your neighbor also installs a wireless LAN segment in his home, his system may interfere with yours and vice versa. Furthermore, if he uses a higher power system than yours, his wireless LAN may completely disable yours by whiting out your wireless traffic. The two competing systems don't necessarily even have to be on the same channel or even be in the same spread spectrum technology. They can still have this whiting out problem. So license-free bands do have their disadvantages. There are going to be 3 license-free ISM bands that you'll want to focus on. The 900 megahertz, which is actually 902, the 2.4 gigahertz band, and the 5.8 gigahertz band. Of these, the FCC has specified that wireless LANs can use the 900 megahertz and the 2.4 gigahertz bands. 900 megahertz, which begins at 902 and goes to 928, has been largely abandoned by the industry. But the 2.4 gigahertz ISM band is used by all 802.11, 802.11b, and 802.11g compliant devices, and is by far the most populated space of the 3 bands that we see in this particular discussion. The 2.4 gigahertz ISM band is bound by the 2.4 gigahertz and 2.5 gigahertz ranges as defined by the FCC. Of the 100 megahertz between 2.4 and 2.5 gigahertz, only the frequencies 2.4 through 2.4835 are actually used by wireless LAN devices. The principal reason for this limitation is that the FCC has specified power output only for this range of frequencies to make it license-free. The 5.8 gigahertz ISM band is normally called the 5 gig ISM. The 5 gigahertz ISM band is bound by 5.725 and 5.875, which does yield 150 megahertz of bandwidth. This band of frequencies is not specified at all for use by wireless LAN devices, so it does tend to present some confusion because the 5.8 gigahertz band overlaps part of another license-free band, which is called the upper UNII band, which is, of course, what 802.11a uses. And that's where we start to see the license-free UNII bands being used. The 5 gigahertz UNII band are made up of 3 separate 100 megahertz wide bands, which are usually used by the 802.11a compliant devices. These 3 bands are known in the 5 gigahertz range as the lower, the middle, and the upper bands. Within each of these 3 bands, there are 4 non-overlapping OFDM channels that are each separated by 5 megahertz. The FCC mandates that the lower band be used indoors, the middle band be used indoors or outdoors, and the upper band be allocated only for outdoor use. Now, since access points are mostly mounted indoors, the 5 gigahertz UNII bands would allow for 8 non-overlapping access points indoors using both the lower and the middle UNII bands. And that's how we can kind of quantify exactly how our license-free bands will fit into our wireless LAN environment. Another major standards organization which has really helped us in the wireless LAN area is the IEEE. The Institute of Electrical and Electronic Engineers is really the key standards maker for most things that are related to all information technology in the United States. The IEEE does create its standards within the laws that have been set forth by the FCC, so they are fully compliant. And it's really part of the mission of the IEEE to develop standards for wireless LAN operation within the framework of FCC rules and regulations. So typically, everything that we see from the IEEE is considered safe.